The objective today is to describe the benefits of using fiber optic cables. So the first thing I'll do is suggest a resource for you to go to if you wanted to learn more about fiber optics. The second thing is we're going to talk about how fiber optics is using photons instead of electrons. So there you go, right here, and using it instead of using electricity here, we're going to use light. That also means that the way you transmit is going to be different than the way you receive, at least in fiber optic cabling. We'll talk about what makes up fiber optics, the core. Then we're going to talk about the speed. These cables can reach some pretty amazing speeds. And then we're going to talk about how the growth of fiber optics is going in terms of like the industry. I want to finish the lesson by talking about the concept of microns. You know, every teacher has like multiple mini objectives as well as just like the number one big objective to accomplish during each lesson. For us here, this vocab word is definitely something I want you to walk away with as well. So here's that additional resource. All you have to do is go to YouTube and type in Linus Tech Tips and then type in copper versus fiber. He does a great short video to compare these two concepts, and he'll discuss different things than I plan to in this video. In class, I'm always encouraging my students to use other resources, other people, other teachers to learn the things that I am trying to teach them. All right, so when we're talking about fiber optics, essentially we're talking about electrons versus photons. In fiber, bits are transmitted as pulses of light, which means they are immune to electrical interference and eavesdropping. This, in my mind, is the first two big benefits you'll not only want to remember, but you'll want to consider when you're wiring up your own networks, whether it's at home or maybe in a business setting in the future. Now, each strand can only carry data in one direction, so that means you obviously need at least two strands, one to transmit, one to receive. And when you're using a cable as a backbone, fiber optic cable as a backbone for a network, you'll usually see these come in bundles of 12 or more. Now in class, we often look at PCB boards with TX and RX written on them. So the concept is similar in terms of one cable or one core. And here you go, if you did not know what a fiber optic cable looks like, it basically has this glass core where the light travels through. So over here, you'll need at least one to transmit the data and one to receive. Here's that picture again, and so quick think right here, what is the core made of? I mentioned it's glass. But the thing is, the ones and zeros aren't traveling like in this picture, they're traveling more like in this picture. The light is bouncing at different angles through the glass. Okay, so let's go back here. Overclocking cable isn't a real thing. I just thought that would be a cool title. But people usually talk about overclocking CPUs, that is to get the processor to go faster. Well, with fiber optic cabling, you can get data to transmit faster. And in fact, research has shown that we can get up to 159 terabits a second over a length of 1045 kilometers. I don't know why it's 1045 and not just like 1,000 kilometers, but going to this link, this seems like one of those websites that'll be a bit over my head. But after reading information on this link, I'm pretty impressed with how fast we can transmit data. It says the Network System Research Institute and Fujikura Limited developed a three-mode optical fiber capable of wide-band wavelength multiplexing transmission with standard outer diameters that can be cabled with existing equipment. See, already completely over my head, maybe over your guys' head too, but that's where I got the number from, 159 terabits a second. That's insane speeds. I did continue to research fiber optic cable speeds and found some good information on a geek.com website. And just also for comparison, I found this link to Extreme Tech that was from 2013. It's fascinating how quickly things in technology progress. So a headline in 2013 was World's Fastest Wireless Network Hits 100 Gigabits per Second, can scale to terabits. Game researchers have combined photonics and electronics to create a world record-breaking wireless network that can send and receive data at a heady 100 gigabits per second. To create the signal, two laser beams carrying the data are mixed together using a photon mixer made by NTT Electronics. The tricky thing about fiber optic cables is all these different connector types. You got the mechanical transfer register jack, fiber channel or ferrule connector. You have a medium interface connector, a sub-miniature type A straight tip, a straight connection, and a locking connection. Now, if people think fiber optics will eventually replace copper, I imagine they'll want to get these options for connector types down. That way people don't go insane with all the possibilities that they have for connectors. And that leads me to tell you why fiber hasn't already taken over. It's because installing copper is just so much easier and less time consuming. So why fiber optics hasn't taken over the world yet. Now you have single mode and multi-mode fiber optic cabling. Apparently, though, only one of them gets a hyphen. I suppose that's an English language thing. But your think right share here is predict which one do you think is the most common one? The single mode fiber optic cabling or the multi-mode? I mean, at the end of the day, they are both just delivering ones and zeros to you. Which one is the more common one? Forgive me, I totally asked you the wrong question there because according to this website, single mode is for long distance, while multi-mode is for the network set up in like a building or a house. Now, when I go to this site, it's the fiberopticshare.com site. It says that when planning to build a fiber optic network, the first decision you often encounter is single mode fiber or multi-mode fiber. Hopefully, I can make the decision easier for you. So then the author of the article goes on to say, to make a better choice, we'd better have an overall understanding of single mode fiber. So then they'll talk to you about that. Generally, single mode fibers have a small core size, so this is 9 microns right there. That's how you say that abbreviation. Multi-mode fibers have larger cores, all right. Two types of larger core. You got 62.5 microns and 50 microns. They got 3 different types of indexes they're showing here. It says single mode fiber needs to be used with laser diode based fiber optic transmission equipment. Single mode fiber cable systems are usually more expensive, even though the actual cost of single mode fiber cable is cheaper. Rolling down here to Cisco devices. Multi-mode transceivers also consume less power than single mode transceivers. Oh, I love Venn diagrams, so here's a quick look at single mode versus multi-mode. Now, of course, they're both using glass. They can both be simplex or duplex. And of course, they have all these types of connectors that either of them could use. Conclusion, generally, multi-mode fiber is more cost-effective choice for data center applications up to 550 meters. So going right back to what I was saying, at the end of the day, single mode is for long distance and multi-mode is for networking. So the last thing we need to talk about is microns. The first noticeable difference is in core size. So microns, just a cool word to say. Your think right share, how many microns are in a millimeter? And you'll use this picture to help you. See here we have a centimeter rule. So here's 1 centimeter, 2 centimeter, and so on. That means each of these is a millimeter. So how many microns in a millimeter? I went and found some cool pictures for you to see. Apparently a bacteria is 3 microns. Red blood cell is 5 microns. This is the size of dust. And here is the size, the thickness of human hair, this giant thing. You can see that in this picture. Here's the strand of human hair. This is ragweed and dust mite feces and pollen. So all things that are being measured in microns. So multi-mode fiber is cheaper than single mode. It will even work with LEDs, while SMF, that is single mode, that's the abbreviation for single mode fiber. This usually needs lasers. When I say it will even work with LEDs, that's pretty cool. That fiber, multi-mode fiber can work with these LEDs. You college-bound kiddos out there, a lot of colleges have laser labs. I was in the Colorado School of Mines this last summer, and I was checking out their laser lab. It's a pretty cool place for you to go and experiment in. Just one more picture to kind of drive home the point of how fiber optic cabling works. You're thinking right here, really easy here. What do you see in the picture? let you just pause here and digest all this information. So that's the end of my lesson here. You should be feeling way more powerful or knowledgeable by now. I know it's kind of funny to have a single lesson on a cable type, but I feel like this was one of those futuristic lessons of mine where you younger people who are watching this will probably work with fiber optics much more than I ever did. And ultimately, you'll decide what to use when building networks of your own. When you're tasked with the decision to choose between copper and fiber optics, something that comes to my mind is something that I always tell my students where you're free to make whatever choice you want. You're not free from the consequences of your choice. That fiber optic cabling is pretty nice. I don't think there's going to be a large price difference, but I think the number one thing that you need to look for is if that's even possibility for the hardware you have in whatever lab or network setup you're looking at. I rarely see those fiber optic ports on computers, so don't get so into the benefits of fiber optic cabling that you forget like the very obvious. So the end of the lesson, I really like to think of these IB attributes as I finish a lesson, like what was this lesson similar to? Is it all about being open-minded to maybe new technology? Maybe you're a risk taker there because you're thinking of being brave and courageous using some technology that is not as common because of all the benefits that exist with fiber optic cabling. And at the end here, your DOL is just to tell me 3 of the biggest benefits you remember about using fiber optic cables.